today we will start electrostatics. Basically, electricity, we have to take two topics. One is known as electrostatics and second electrodynamics. Electrostatic deals with static charge. Generally we say charge in equilibrium. Okay, generally we say charge in equilibrium. And in electrodynamics we deal in flow of charge. And that is known as current. Okay, so the main entity in electricity in which we will deal, that is charge. Here there is flow of charge and this is static charge. So let's try to find what exactly is charge. So charge was known from ancient time. Even if you see, when you comb your hair, if you bring the comb near the dust particle, it has a tendency to attract the dust particles. That is because of the charge. So the modern theory of charge is known as electronic theory. Electronic theory of charge. Today we know the structure of atom. Okay, we know that each atom is made of nucleus, there are protons and neutrons, and electron orbit around them. The Coulomb's law in vector form okay, for that suppose we choose any coordinate system and this is the origin. If we choose any coordinate system, this is the origin. So one of the particles is kept here, this is 1, it has charge q1 and its position vector, as you can see, if you join this line from origin, this is suppose r1. And suppose the second charge is somewhere here, q2, and the position vector, this is suppose r2. Recall that the position vector is a line joining from origin to that position. So here this is the position vector of charge q1, this is the position vector of charge q2. So from vector we know that if you join these 2 points, then this vector we represent r12. If you join a line, means if I are drawing a vector from 1 to 2, then we say this is r12 and r12 will be r2 minus r1. Okay, this is r2 minus r1 from triangle law, you know this. So magnitude of this will be magnitude of r2 minus r1. Okay. Now from Coulomb's law, the magnitude of the force will be F will be K q1 q2 divided by square of the distance between them. And direction of the force was, if they have similar sign, then it will be repulsive. If they have opposite sign, then it will be of attraction. So what I can do now, I can remove this mod sign and now we will take sign of the charges. If product of q1 q2 is positive, that means the sign is same, so it must be repulsive force. It must be repulsive force. Now let's be more specific. Suppose I am taking the force exerted by 1 on 2. So we will write F21. This means force on particle 2 by particle 1. Okay. Now suppose this notation we are using, I am suppose if here also I am finding force on 2 by 1. I am finding force on 2 by 1. Okay, as you can see that if the product of these two is positive, so the force exerted by 1 on 2 will be in this direction. That is along the vector 1, 2. This is 1, this is 2. So this is along the vector 1, 2. Okay, if the product of these two is negative, then the force will be in this direction, that is opposite to the vector r1, 2. Okay, so to represent direction we use unit vectors. R